This is how I made these light up PCB pins. Using multicolor printing technology, you can do quite a lot with PCBs these days. Services offered by PCBWay and JLC PCB allow you to put pretty much any picture on a circuit board now. For the microcontroller, I went with a STM32C110, which is an ARM Cortex M0 Plus. It has a voltage range of 2 volts to 3.6 volts, low power modes, such as sleep, stop, standby, and shutdown, and a serial wire debug interface, which is a two-wire interface, which will help minimize the amount of pins we need to program it. This is a basic outline of our charging circuit. For the charging circuit, I went with an existing single-cell LiPo charger, the TPB4056A. It has some nice features such as two indication pins called PPR and charge. PPR being the input voltage detection to the pin, whether it's plugged in or not, to the voltage source, and a charge pin indicating the charge status of the battery. In addition to that, two passive resistors set the minimum charging current and standard charging current to the battery. Time for a little demonstration. So when the USB-C is plugged in, the microcontroller detects the input voltage of 5 volts from the USB-C and that the charge state is low, which we indicate using a red status from the LEDs. And if it's fully charged, we have it blinking green. Pretty simple. Next, we're going to talk about the wake up pin, which is a dedicated pin on the microcontroller for waking it up from a low power state. To do this, we simply use a button with a pull resistor. So when we push the button, we wake it up from its sleep state. And then after that, you can reconfigure the button to have it cycle through multiple different color modes for the pin. Next, for programming the MCU, I used a serial wire debug pins. If you look on the board, I put these four little circular pads for the headers for the programmer pins. Using pogo pins, which are simply just some spring-loaded pins, I can use it to clamp down on those pads, program the board. This is using the serial wire clock and data, along with the 3.3 volts and ground to power the MCU. It's as simple as just clipping it on, plugging in your programmer, and you're ready to go. And last but not least, for supplying power to the microcontroller, I use a simple linear regulator, MCP 1700. It's a standard linear regulator with an input voltage of 2.3 volts to 6 volts and an output voltage range of 1.2 volts to 5 volts, depending on the version you choose. I decided to go with the 3.3 volts, which is perfect for our microcontroller. If you like this video and want to see more cool technology in the future, please leave a like and a subscribe. We'll see you then.